Hello, this is MEI Further Maths Core Pure. We're in the first vectors section and on the first video on using vectors. You will meet 2D vectors in AS Mathematics. If you have already completed this topic, you may want to skip to the slides on 3D vectors. If you have already completed the whole A level, this video will be revision and you could move straight on to the next video. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. You've already met vectors at GCSE. You'll already know that a vector may be written as AB with an arrow over it, indicating that you're moving from A to B, or it simply may be given a letter name. In 2 dimensions, we can write our vector in component form as a column vector. Like coordinates, x comes first and then y. In printed text, vectors will generally be given in bold. It's a good idea in handwriting to make sure that it's clear that you are using a vector by underlining it, as it is difficult to indicate bold text. Vectors can be added, subtracted and multiplied by a scalar. Pause the video for a moment while you work these out. OK, the vector A plus B, adding the components 4 plus 1 is 5, minus 1 plus 2 is 1. On the diagram you can see that this is the vector A and this is the vector B, and if I do A followed by B, then I do get the vector 5, 1. A minus B, 4 take away 1 is 3, minus 1 take away 2 is minus 3. And you can see that this vector here is minus B, so if I do A followed by minus B, then I do indeed get 3 minus 3. And finally, 2 lots of B is 2, 4. And you can see here that B followed by B gives me the vector 2, 4. The modulus or magnitude of a vector is the size of it, the length of it, and we work that out using Pythagoras' theorem. For example, if I have the vector B equal to 3, 2, then the magnitude of B is equal to the square root of 3 squared plus 2 squared, which is root 9 plus 4, which is root 13. When working in 2 dimensions, we can use unit vectors I and j. I is the vector 1, 0 and j is the vector 0, 1. And we can write any vector as a combination of i's and j's. A numerical example, the one we had before, if I've got the vector b 3, 2, then I can write that as 3i plus 2j. Sometimes we want unit vectors in other directions. What we do is we take any vector in that direction and make it 1 unit long. We do that by dividing by its size. So the vector A divided by the size of the vector A will give us a unit vector. Here's an example with our vector 3, 2 again. We already know that the magnitude of this vector is root 13. So if I divide that vector by root 13, I'll have a vector of size 1. So 1 over root 13, 3, 2. Parallel vectors have the same direction. Pause the video for a moment while you work out which of these vectors are parallel to each other. OK, they're parallel if they can be written as a scalar multiple of each other. So minus 4, 2 is just 2 lots of minus 2, 1. So those two are parallel. And 8 minus 4 is minus 4 lots of minus 2, 1. So that's parallel as well. And of course, if it's parallel to minus 2, 1, it will also be parallel to minus 4, 2. This one, however, you can't multiply by anything to get one of the other three. So that one is not parallel to the others. The position vector of a point is simply the vector going from the origin to that point. So if the point P has position vector minus 4, 3, it must be here. And there's its position vector. Similarly, the point Q must be here, so that its position vector is 3, 2. Pause the video for a moment while you find the vector PQ. OK, to get from P to Q, I can do from P to O, and then from O to Q. P to O is minus P, and O to Q is the vector Q, and that's going to be 4 plus 3 is 7, and minus 3 plus 2 is minus 1. And you can see that the vector from P to Q is 7 minus 1. In 3 dimensions, we add an extra axis and an extra unit vector k. An example of a column vector written in ijk form would be this. Here's my vector b equals 1, 2, minus 3. And I can say that that's equal to I plus 2j minus 3k. We can handle 3D vectors in much the same way as 2D. They can be added, subtracted and multiplied by a scalar. The magnitude of a 3D vector is found by using Pythagoras in 3 dimensions. OK, here you can see that I've got some vectors in 3 dimensions. I can move them around and you can see their coordinates changing. Here I've got the vector OA, which is 2, 4, 3. If I want to find the size of this vector, I need to look at 2 right-angled triangles. Looking at this triangle here, you can see that the length OF is going to be the square root of 2 squared plus 3 squared. That means that this length squared is 2 squared plus 3 squared, and then I add the square of that length, and that will give me the square of this length. So you can see from this diagram that if I add the squares of each of the 3 components, then I will get the square of that length there. So the magnitude of the vector A is the square root of 2 squared plus 4 squared plus 3 squared, which is root 4 plus 16 plus 9, which is root 29. Pause the video for a moment while you work out the length of vector B. OK, the magnitude of vector B is the square root of minus 4 squared plus 2 squared plus 1 squared. That's the square root of 16 plus 4 plus 1, which is root 21. There are more notes on integral or in your textbook on using vectors. That's the end of this short video. The next video in this series is on the scalar product of 2 vectors.